This video will go through ionic compounds, what they are, why they form, how to name them, and how to write chemical formulas for them. We'll start with what they are. Ionic compounds are pure substances made of a metal and a nonmetal that are chemically linked together. All ionic compounds have the common properties of having high melting points. They form crystals, which are very regular arrangements of particles. The diagram down here shows the arrangement of those particles. So we have the generally larger metal atom or ion next to the non-metal ion. And you get this regular repeating pattern of metal, non-metal ion, which forms that crystal. Ionic compounds, for the most part, will dissolve in water to form solutions that conduct electricity. And they are solids at room temperature. When forming an ionic compounds form when one or more electrons move from a metal atom over to a non-metal atom. So, in other words, metal atoms will lose electrons and nonmetals will gain electrons. So from the periodic table, you will need to identify which atoms are metals, which ones are nonmetals. We will go through the example of sodium and chlorine. So here, sodium is going to be our metal. So here is sodium, which is going to be our metal. And here we have chlorine, which is our nonmetal. We have the Bohr-Rutherford diagrams for these two elements. We have 11 protons, 12 neutrons, and 11 electrons orbiting this nucleus here, which makes this sodium. We have 17 protons in the nucleus, 18 neutrons. The 17 protons makes this chlorine. And then chlorine has the 2, 10, and 17 electrons orbiting around that nucleus. Now, ionic compounds will form when the valence electron or valence electrons from a metal atom transfer over to a nonmetal. So in this case, sodium has one valence electron, this one valence electron, and it will give up that valence electron to chlorine. Remember that sodium here has a full valence or a full set of electrons underneath this valence electron here. So by losing this electron now, these 8 electrons will become the valence electrons, and so sodium will be happy now. It has a full orbit of electrons. Here with chlorine, in the outer shell, chlorine has 7 valence electrons and has room for one more to get to that complete orbit. So by sodium transferring an electron over to chlorine now, they are both happy in this case. So now here we have sodium ion. It has lost that valence electron, has now gained a charge of +1, and chlorine has now gained that electron from sodium, now has a full orbit of electrons, and has also gained a charge of -1. Now this positive and negative charge will attract these two ions together, and they will form a chemical link called an ionic bond. And so we'll go through what is a chemical bond here. So a connection between atoms or ions is known as a bond. An ionic bond results when a positive ion is attracted to a negative ion. So in this case, the positive charge around this lithium ion is going to be attracted to that negative charge around this fluorine ion. And so they will interact together and form that ionic compound. Now, there are rules for naming ionic compounds, and they're pretty straightforward. There's 2 of them. The first rule when naming an ionic compound is that you always name the metal ion first. So you write the name of the metal ion, and then you name the non-metal ion second, and you change the end of that non-metal ion to "-ide". So in this example here, we have NaCl. When we go and find the names for these symbols on the periodic table, Na is going to be our metal, which in this case is sodium. So we write the name of the metal first, and then we write the name of the non-metal. In this case, we'll have chlorine, and then we change the end, in this case, the INE to IDE. So sodium chloride, I'll write this a little bit better. So sodium chloride, or sodium chlorine, will become sodium chloride. So we change the N to IDE. And note in the chemical formula as well, it's always metal first, non-metal second. So those are normal conventions as well. So conventions are name of the metal first, name of the non-metal second. Change the end to IDE. So in the following examples, we can name the following ionic compounds. Just note that in ionic compounds, these subscript numbers are not included in naming ionic compounds. So in this case, if we have the chemical formula Li2O, we simply follow the rules that was on the previous slide. So we name the non-metal first. Name the metal first, and then name the non-metal second, change the end to IDE. So in this case, Li2O, we would name as lithium oxide. In the following example, here we have a subscript number next to the non-metal, and same rules apply. We do not use subscript numbers in naming our ionic compounds. We simply follow the two rules as on the previous page. So we have our metal and our non-metal, and we simply write out the name of the metal. So in this case, we have magnesium, and then we have our non-metal, which is bromine, and we're going to change the end there to IDE, so we get magnesium bromide. Work on the next two and see what names you come up with, and we'll take that up in class. So we can also use the name of our ionic compound to find the formula of the ionic compound. And here there are several steps involved. So we write the elements that are involved. We write the symbol for the elements that are involved. We write their charges over top of the elements, and we can determine their charges from the periodic table, from where they're located. We can then use what's called the crisscross rule. So we cross the charges, so we cross the numbers, but not the positive or negatives. And then where applicable, we reduce to the lowest whole number ratio. So if we can, we reduce our numbers. So let's look at the following example for sodium chloride. So we write the symbol for the elements involved. So sodium is Na. Chloride is Cl. We'll write their charges over top of the symbols for the elements. So from the periodic table, sodium is in column 1, so when it becomes an ion, it will gain a charge of +1. Chlorine is in that 7th column, or that halogen family, or 17th. So when it becomes an ion, it will gain a charge of -1. We then do what is called the crisscross rule. So we'll take just the number above the symbol for Na. We will cross it over, and this will become the subscript for chloride. We take the number above chloride, cross it over, so it becomes the subscript for sodium. And remember, we don't write subscript ones, so we get simply NaCl. And then where possible, we reduce to lowest terms. We're already in our lowest terms. So we get NaCl as our chemical formula for sodium chloride. So we'll do one example here where we find the following formula for the ionic compounds for magnesium oxide, and then try out lithium sulfide for yourself. So for magnesium oxide, we'll follow the same rules that we did before with sodium chloride in the previous example. So we'll first start by writing the symbol for each element. So magnesium is Mg, oxide is for oxygen, and that just gets the symbol O. When we determine charges from the periodic table, so magnesium is in column 2, so it will lose 2 electrons and gain a positive 2 charge. Oxygen has 6 valence electrons, so it needs to gain 2 electrons, and when it gains those 2 electrons, it gains a negative 2 charge. Once we've determined the charges, we simply take the number and the number alone. Notice I've circled the number, and we'll cross it over so it becomes the subscript. So the 2 above magnesium, we will move it over so it now becomes the subscript number next to oxygen. We will take the number 2 above oxygen and move it so it becomes the subscript number beside magnesium. So we can write our formula as Mg2O2. So the 2 that was above oxygen is now next to magnesium. The 2 that was above magnesium is now next to oxygen. Now here we can reduce our numbers further down. So in this case, because we can divide each of these subscript numbers by 2, we will do that. That will reduce us to lowest terms. So 2 divided by 2 is 1, 2 divided by 2 is 1, and our final formula is MgO. So this would be the chemical formula for magnesium oxide. For lithium sulfide, you should get Li2S as the formula. So that is the end of this video for ionic compounds.